This section is 6.6.2 DeMoivre's theorem. This video is about DeMoivre's theorem to find powers of complex numbers and find the nth roots of a complex number. Who was French mathematician DeMoivre? Abraham DeMoivre was born in a poor Protestant family in 1667 in France. In 1685, he fled to England to escape religious persecution. He became a naturalized British citizen in 1707. He was elected to the Royal Society of London in 1697. He was a devout Christian. He believed that mathematics and science were compatible with religion, and he saw them as ways to better understand the wonders of God's creation. He wrote an essay upon the method of fluxions, in which he used mathematical analysis to interpret the prophecies of Daniel. He believed that mathematics was a tool that could be used to glorify God. He discovered roots of complex numbers and died in 1754 in London and buried in Westminster, London, England. R.I.P. Rest in peace. Trigonometric form of a complex number. The trigonometric form of the complex number z equals to a plus bi is z equal r times cosine theta plus I times sine theta, where r equals to square root of a square plus b square and tangent theta equals to b over a, where a is the real part of complex number and b is the imaginary part of the complex number. Note: choose theta in the quadrant in which z equals to a plus b lies. If z equals to a plus b lies in quadrant 2, then theta equals pi minus tangent inverse b over a in absolute value. Number 2, if z equals to a plus bi lies in quadrant 3, then theta equals to pi plus tangent inverse b over a absolute value. Number 3, if z equals to a plus b lies in quadrant 4, then theta equals 2 pi minus tangent inverse absolute value of b over a. DeMoivre's theorem. If z equals to r times cosine theta plus I sine theta, then z raised to the power n equals to r times cosine theta plus I sine theta raised to the power n equals to r raised to the power n times cosine n theta plus I sine n theta, where r equals to square root of a square plus b square and tangent theta equals to b over a. Here is an example 1, finding a power of a complex number. Use DeMoivre's theorem to find the power of the complex number. Write the result in standard form: 5 times cosine 20 degrees plus I sine 20 degrees to the power 3. So let's start with this. 5 times cosine 20 degrees plus I sine 20 degrees raised to the power 3. Now 5 is the modulus and 20 degree is the angle. So we're going to raise this power 3 to the modulo and multiply the power 3 with the angle. So we have this 5 to the third times cosine 3 times 20 degrees plus I times sine of 3 times 20 degrees. Now we simplify this. 5 cube equals to 125 and this becomes cosine 60 degrees plus I sine 60 degrees. Now use the unit circle and cosine 60 is equal to 1/2, sine 60 equal to square root of 3. So we have now 125 times 1/2 plus I times square root of 3 over 2. Now distribute 125. So it becomes 125 times 1 over 2 plus I times 125 times square root of 3 over 2. So you multiply 125 with 1. So it becomes 125 over 2 plus I times 120 times square root of 3 over 2. So that's the standard form of the complex number. Example 2. Use DeMoivre's theorem to find the power of the complex number. Write the result in standard form. 2 plus 2I to the power 6. Solution. A equals to 2, B equals to 2. Step 1. Rewrite 2 plus 2I in trigonometric form. So R equals to square root of A squared plus B squared. So we substitute A equals 2, B is equal to 2. So this becomes square root of 2 squared plus 2 squared. 2 squared is 4, 2 squared is 4. So we have a square root of 4 plus 4, which is square root of 8. Therefore, R equals to square root of 8. So step 2, plot 2 plus 2I to find out in which quadrant 2 plus 2 lies. So you draw the real axis like an x-axis and imaginary axis like y-axis. So you go 2 units to the right because 2 is positive, and then from there you go 2 units up and you get this point 2 plus 2I and connect this point to the origin to dots. So it looks like from the picture we can tell that this and 2 plus 2 lie is in quadrant 1. So therefore theta equal to simply tangent inverse B over A. Now we substitute A is 2 and B is 2, not I 2. So this theta equals to tangent inverse 2 over 2. Simplifies to tangent inverse 1, which is from the table of values is equal to pi over 4. Step 3. Write the trigonometric form 2 plus 2I is equal to R times cosine theta plus I sine theta. Now we substitute R equal to square root of 8 and theta equals to pi over 4. So this becomes square root of 8 times cosine pi over 4 plus I sine pi over 4. And now we raise the power 6. So this becomes 2 plus 2I to the power 6 equals to square root of 8 times cosine pi over 4 plus I sine pi over 4 to the power 6. Now we apply DeMoivre's theorem, and that says you raise this power 6 to the modulo square root of 8. So this becomes square root of 8 to the power 6. And you multiply the power with the pi over 4. So this becomes cosine 6 times pi over 4 plus I times sine of 6 times pi over 4. So you simplify this one using calculator, you see 512, and this becomes 2. You can divide 6 by 2 and 4 by 2, so you have a cosine 3 pi over 2. Similarly, this plus I times sine 3 pi over 2. From the unit circle, we can find cosine 3 pi over 2 is 0 and sine 3 pi over 2 is 1. So you have a 512 times 0 minus I1. Now 0 minus I1 just and minus I. So this becomes negative 512. Finding the nth root of a complex number. The n distinct nth roots of z equals to r times cosine theta plus I sine theta, or z sub k equals to nth root of r times cosine of theta plus 2 pi k over n plus I sine of theta plus 2k pi over n. Or you can say z sub k equals to nth root of r times cosine of theta over n plus 2 pi k over n plus I times sine of theta over n plus 2k pi over n, where k is 0, 1, 2 up to n minus 1. When k is bigger than n minus 1, then roots begin to repeat. Example 3. Find all solutions of the equation x cubed minus 1 minus I equal to 0. So first step is find r. So let's start with the equation x cubed minus 1 minus I equal to 0. So you isolate x cubed. So you move 1 minus I to the right side. Since this is minus, so it becomes plus 1 minus I. So we have x cubed equal to 1 minus I. Now a is 1, is a real part of the complex number, and b is equal to the coefficient of I, which is negative 1. So now r equals to square root of a square plus b square. Substitute a equals to 1, b equals to negative 1. So this becomes square root of 1 square plus negative 1 square. Now 1 square equals to 1, and negative 1 square is also 1. So we get square root of 1 plus 1, which becomes square root of 2. Now after finding the r value, we will find angle theta. To find the angle theta, first find 1 minus I lies in what quadrant. So you plot 1 minus I. So to plot this one, you draw the real axis like a horizontal x-axis, and draw the imaginary axis just like the y-axis. Now 1 is real part, so 1 is positive, so you go 1 unit to the right on the real axis. Since a negative I, so you go 1 unit down to the imaginary axis and plot the point and connect this point with the origin through dotted lines. Now you can see this complex number lies in quadrant 4. So now theta equals to 2 pi minus tangent inverse absolute value of b over a. So now you substitute b equals to negative 1 and a equals to 1. So we have theta equals to 2 pi minus tangent inverse of absolute value of negative 1 divided by 1. Simplify, you have theta equals to 2 pi minus tangent inverse 1. Now you can use the table from the table of values, tangent inverse 1 is pi over 4. So now we have theta equals to 2 pi minus pi over 4. In order to subtract, we have to have same denominators. So we have LCD is 4. So to multiply 2 pi with 4 and divide by 4. So we have 8 pi over 4 and minus pi over 4. Now we have same denominators. So we can subtract numerators. So 8 pi minus pi would be 7 pi over 4. So theta equals to 7 pi over 4. Now roots of the form, substitute n equal to 3, square root r equals square root of 2, theta equals 7 pi over 4 in the nth root formula, which is z sub k equals to nth root of r times cosine of theta over n plus 2 pi k over n plus I times sine theta over n plus 2k pi over n. We can substitute n equals to 3, r equal to square root of 2, and theta equals to 7 pi over 4. So that we get z sub k equals to cube root of square root of 2, because r is square root of 2 and n is 3. So it becomes cube root of square root of 2 times cosine of theta is 7 pi over 4 divided by 3 plus 2 pi times k over 3 plus I times sine of theta is equal to 7 pi over 4 divided by 3 plus 2k pi divided by 3. Now we simplify. This cube root of square root becomes 3 and 2 here 6. Sixth root of 2 times cosine of 7 pi over 4 times 1/3 becomes 7 pi over 12 plus 2 pi k over 3. Similarly, plus I sine 7 pi over 12 plus 2k pi over 3. Now we substitute k equal to 0 in z sub k, the sixth root of 2 times cosine 7 pi over 12 plus 2k pi over 12 plus I times 7 pi over 12 plus 2k pi over 3. So this becomes z sub 0 equals sixth root of 2 cosine of 7 pi over 12 plus 2 pi and k becomes 0, so it will be 2 pi times 0 over 3 plus I times sine of 7 pi over 12 plus 2k times 2k 0, so we have 2 pi times 0 over 3. So we simplify, so you have a z sub 0 equals to sixth root of 2. So times cosine 7 pi over 12 plus I times 7 pi over 12. So that's the solution number 1. Now substitute k equals to 1 in this formula z sub k. So this becomes z sub 1 sixth root of 2 times cosine of 7 pi over 12 plus 2 pi times k is 1, 2 pi 1 over 3 plus I times sine pi over 12 plus 2 pi times 1 over 3. Now we simplify. So you convert 3 into 12. So you multiply top and bottom with a 4. So we have z sub 1 equals to sixth root of 2 times cosine 7 pi over 12 plus 2 pi times 4 divided by 3 times 4, 8 pi over 12 plus I times 7 sine of 7 pi over 12 plus 2 pi times 4 divided by 3 times 3 times 4, so we 8 pi over 12. Now we simplify. They have same denominators. So it becomes z sub 1 is the 6th root of 2 and cosine of 15 pi over 12 plus I sine 15 pi over 12. So this is solution number 2. To find the solution number 3, substitute k equals to 2 in the formula. Z sub k equals to nth root of r times cosine of theta over n plus 2 pi k over n plus I times sine theta over n plus 2k pi over n. So this becomes z sub 2 equals to 6th root of 2 times the cosine of 7 pi over 12 plus 2 pi k times k is 2, so be 2 pi times 2 over 3 plus I times sine of 7 pi over 12, and this becomes 2k pi times 2 over 3. Now we multiply top and bottom 4 here, and we have a equals to 6th root of 2 times the cosine 7 pi over 12 plus 2 times 2, 4 times 4 pi over 3 plus I times 7 pi over 12, and this becomes 4 pi over 3. Now in order to simplify, we have to multiply here 4 here and 4 here. So we get z sub 2 equals to 6th root of 2 times cosine of 7 pi over 12 plus 4 pi times 4 is 16 pi over 3 times 4 is 12 plus sine of 7 pi over 12 plus multiply 4 here and 4 here become 16 pi over 12. Now they have same denominators, so we can add. So z sub 2 equals to 6th root of 2 times cosine of 7 pi plus 16 pi 23 pi over 12 plus I times sine of 7 pi plus 16 pi 23 pi over 12. So that's the solution number 3. So we write all the solutions. The first solution is 6th root of 2 times cosine 7 pi over 12 plus I times 7 pi over 12. Second solution is 6th root of 2 times cosine 5 pi over 4 plus I times sine pi over 4. Third solution is 6th root of 2 cosine of 23 pi over 12 plus I times sine of 23 pi over 12.